There is one project I would like to talk to you about today in detail, and I think it truly illustrates the power of community. It's called Neptune Canada, and it's part of the Ocean Networks Canada Observatory. Popular Science recently named it one of the universe's 10 most epic projects. Oceans cover nearly 3/4 of the Earth's surface and makes 99% of the world living space. Ocean provides us with, of course, food, water, carry our cargo ships, shape our weather. The medical community is developing new medicine based on research of aquatic life. In truth, we are just beginning to understand how our oceans work and how undersea biology, chemical, geological changes affect us. This is why the Neptune project is so important. Neptune Canada is the world's first regional underwater cable observatory network. It includes more than 130 instruments, 400 sensors in the Northern Pacific, linked by over 500 miles of cable, all connected to the internet and constantly collecting data. This data is available freely in an open way to communities of researchers around the world 24 hours a day. Neptune is transforming ocean science and helping to unlock the Earth's secrets. When I first learned about the Neptune, I was so impressed not only by the size and the scope of the project, but even more by the manner it has been evolving. What makes Neptune unique is that the project's success is built on community. Here to talk more about the project is the research team integrator at Neptune Canada, Dr. Maya Huberex. Please join me to welcome Maya. Thank you for joining us. Please, Maya, join us for this. Tell us more about it. Thank you for being here. It's an amazing project. This project is truly unique. So can you tell us more about the scale of this project on what is being in Neptune Observatory?
Yes, I can. It is an amazing project. We've deployed a loop of fiber optic cable 500 miles long off the west coast of British Columbia and Washington State. This loop of fiber optic cable carries power and communications to scientific instruments on the seafloor. What's really unique about our location, we are right beside the smallest of the Earth's major tectonic plates, the Juan de Fuca. And this has allowed us to instrument diverse regions. We go right from the coast, across the abyssal plain on the plate, right out to a mid-ocean ridge. The types of instruments we have, they range from seismometers, instruments measuring temperature, salinity, and we even have video cameras streaming live video from the seafloor.
How deep is it, you said?
It goes all the way from the coast, right out to the mid-ocean ridge, which is 2,300 meters. So
very impressive.
Our research covers many different research themes. Ocean technology, of course, seismology, fluid dynamics, physical oceanography, and biology.
To me, Maya, sorry for interrupting, but to me this project is exciting because not only it is created by one person, it is not the case, but it's an entire organization on a large group of contributors, basically, with Neptune Canada.
Yes. At the University of Victoria, we are managed by Ocean Networks Canada. We are working together with our sister network, Venus. The Venus Coastal Network has shallow water instrumentation where we have deep water instrumentation. But not only that, to design and deploy this infrastructure, we needed the collaboration of many international partners, local in Canada, in the US, in Europe, around the world. For example, I'd like to mention Highland Technologies. These are one of our closest collaborators. They work with the CSSF, the Canadian Scientific Submersible Facility, to manufacture the ROV, or the sub, that we use on the ship to do all our deployments.
Many of the names here that you see in the screen are really customers, Solidworks customers. And I know also many of them use many Dassault System products for simulation or other activities.
Yeah, that's true. We use Solidworks at Neptune Canada to design much of the infrastructure that houses our instruments.
Well, I think congratulations. And also, about Solidworks user. Now, the network is established. Data are available in different communities for new discovery. On what, by the way, I see this equipment. I suspect this is designed with Solidworks, isn't it?
It is.
How big is it? Is it bigger than now, or is it smaller? How big is it?
It's about this big.
This big.
It's bigger than the family dog, but still cute.
Okay, very good. And all designed with Solidworks.
Yes.
Wow. You know, this is not a simple installation on a simple system. Congratulations for this design. So, about the data, where are we going? What are the research going on?
Our project is really community-based. We would like researchers around the world to access our data. Our mandate is to provide our data free of access to anybody. And in fact, that means you can go home and create an account and download all the data that we're acquiring from our seafloor network. Part of the motivation of this is to answer the sort of big science questions that we're interested in, such as, do we see effects of climate change in the Northeast Pacific? We need the collaboration and the input from partners and scientists around the world. For example, here, this is video taken by Wally, the seafloor crawler, at a methane hydrate seep, which is 3,000 feet below the ocean surface. It's amazing that we even have that technology, but what makes it more amazing is that Wally is controlled remotely via the internet by a team in Germany.
So they have a joystick?
They do, yeah. Actually, not quite. You saw the interface up there earlier. All these questions, we have to approach them from a group perspective, using the knowledge of people with different backgrounds. For example, we share knowledge regularly with our seafloor partners in Europe at ESONet, and also with our US partners who have just installed the first stage of their seafloor network, the regional scale nodes, off the coast of Washington and Oregon.